So I made these two vacuum tube oscillators, one VHF and one UHF. These are both some sort of a special kind, but anyways, we are talking about low power. This is the one made with the 6N7 GT tube, and I wanted to try this double triode setup for an oscillator, and I didn't have other types of power triodes, double triodes, and I just had a pair of these tubes. And this tube is not at all intended for high frequencies, just audio frequencies, and the datasheet doesn't even specify the interelectrode capacitances, and this tube is really old. The model dates back to the mid-30s. Anyways, this thing instead runs at like 70 MHz. The specialty of this oscillator relies on the fact that this tube must be biased kinda positively on the grids. It needs a so-called 0 volts bias out of a transformer, probably. And to do this, instead of grounding the grid leak resistors here, I supply these resistors that go on the two grids with like 40 volts maximum out of these transformer, power supply, capacitors, etc. And this will shift the voltages on the grids higher and let the tube conduct much more and have more power. Anyways, you can't push much this oscillator in power like you usually do with other tube setups, because probably because of the skin effect and other factors, these wires here heat up too much, like the wires inside the tube, so there's the risk that these wires pop at too much power. This is not the schematic, this is the study that I made for this oscillator to size a bunch of things. And you can see the grid positive current path, the feedback capacitors, the anode to grid feedback capacitances, and about the coil inductance, capacitor size and frequency. Do you notice something? So these are the resistors for the grid leak network, etc. Some bypass capacitors here and here, the anode supply choke, the main inductor for the resonance. These are the feedback capacitors put from anode to grid in opposite order, of course. And this is just a piece of wire for sustaining the structure, and these are all the power supplies that I made for the oscillators, voltage reading and current reading. Okay, let's try this thing. Scope on for reading the frequency. Here is the probe. Multimeters on. This multimeter is already on. I don't know why. Anyways, anode supply on. Variac just a bit. We have 82 volts of anode supply. Let's pick the probe that is already picking up something. Okay, let's put it here. And we have a frequency of like 71 megahertz and above. Okay. Okay, now let's light up some gas tubes. Let's crank the variac for having like 200 volts of anode supply. That is like 30 volts as grid supply. Okay. Small neon on my patented comb. Okay. Neon starter. Okay. MTX90. Okay. Nixie tube. We have kinda 50 milliamperes of consumption. A bit more when discharging. $200 volts. Okay, for the final test, light up, you idiot. 250 volts of anode supply, not more. Argon. Ooh! I burned myself. RF burn. On the pins. Okay. Almost 75 milliamperes of consumption, but I zeroed the variac anyways. Okay, now let's use it as a transformer. Anode supply on, variac for having 100 volts of anode supply, that's enough. Step down transformer, just 2 turns. 12 volts bulb. Okay, now more. 180. Step up. I know it's silly. Ooh, that's magic. I believe it's magic. Do you remember? A bit of resonance effect. Okay. Sadly, I tried to make an high-frequency Tesla coil or inductively coupled plasma, but no, that was not possible because the power is too low, the efficiency is too low, the tube is shitty, I am unlucky. This instead is the UHF oscillator, sorry for the focus, every time. And this uses an EC86 tube or PC86, same thing. And this tube is a single triode intended for UHF frequencies actually. And this thing is capable of running at a maximum of 500 MHz with this setup. Maybe if made better, a bit better, it can do more, I don't know, probably. And I have here a series of interchangeable inductors, as you can see. And these inductors vary the frequency and they go here in place of this. This is the 328 MHz. And the specialty of this oscillator is that it's a grounded grid setup. This tube is intended for being used as grounded grid. And this way there's way less interelectrode feedback capacitance and the tube can go at a higher frequency. Okay, this is how it's made. You can see the chokes on top. These are just for the cathode. The inductor here on the anode and the bypass capacitor of the positive supply. These are the feedback plates from anode to cathode. There's a ground plane made with a sheet of copper that is quite thin here. And other things basically not. There's a special capacitor, you see that brown thing there, that comes from a tube UHF tuner from a TV, and probably the tube comes from there too. And the tube has a stain of rust on it, but the glass doesn't care about rust apparently. And that's how it's made. There's an heavy ground plane tied to the grid, and that's the negative. And as setup, I'm using a digital multimeter for reading the voltage, an analog multimeter for reading the current, 25 milliamperes full scale, just a transformer for both the filament supply and anode supply, no variac, and this is my 300 volts adjustable DC power supply that I made some time ago. You can find the schematic online anyways. So now to read the frequency of this thing, I can't use my scope because although it's 200 MHz instead of 100 because it's unlocked, this thing goes too high in frequency, so I need to use my spectrum analyzer. My spectrum analyzer is so good that it has a 28-inch display. Okay, now the system is running, the oscillator is oscillating, we have 47 volts of anode supply and like 10 milliamperes of consumption. And let's use our spectrum analyzer. Okay, search high, it's running. Okay, black screen, it means we found a carrier. We have 326 megahertz. Let's play with the supply. No volts, volts, no volts, volts, and that's it. Okay, now let's use the 500 megahertz inductor that is basically a short. It's just on the stray inductances of the circuit. We have 122 volts of anode supply, a bit less of consumption because the feedback on the cathode is less capacitively. Okay, let's fire up our spectrum analyzer. That it went out of the screen. Okay, search, noise, search again. $450 and 500. 500 megahertz. Let's see if it's him. No volts, volts, no volts, volts, and here's the carrier. Okay, now let's light up some neons at 328 megahertz. There's the inductor there, the ring, a small inductor. There's the anode feedback plate here where to ignite the gas tubes. Let's bring the voltage, the anode supply to 150 volts DC. Okay. Small neon. We have more than 25 milliamperes of consumption. Neon starter. It's an odd effect on the anode plate, not tube plate. Plate on the pins of the anode. Okay. Okay, now a trick. I have this Unabomber remote here for my room lights. Both my hands are here. Okay, we are using the 433 MHz coil on the oscillator. Let's bring the voltage to like 130 volts DC. That's enough. Like 17 milliamperes of consumption. Let's see. And now it's not working anymore. Why? Because guess, both my hands are here. Guess what frequency this thing runs at? We made a 433 MHz jammer. Oh, let's adjust the frequency. Okay, it works again. Adjusting the frequency, finally. And it's not working anymore. So thanks for having watched my video, and always remember that tube in YouTube means basically vacuum tube.